Do you remember, what do you do when you're multiplying radicals? You can put them all together in one radical. We call it a product property, right? So the product of radicals equals one radical of the product, which is going to be 2 times 8, 16. X times x squared is, remember, you add exponents, x to the third, right? And then you would simplify. You would say, well, is 16 a perfect square since we're taking squares? Yeah, it is. So that one we don't have to worry about. That's 16. And how about the x to the third? Will we be able to take them all out? So how do I break it up? Make it an x squared times x. Right? And now I'll take the square root of every one of those. And that will give me 4x times the square root of x. Dividing. What did we do when we were dividing radicals? You know, if you can, remember, if you look at it and you say, well, if I put them in the same fraction, the denominator is going to cancel. Then you definitely do it. Okay. So if I put this into one fraction, one radical, so it's 8x squared over 2x, then the 2 goes into 8, x goes into x squared. This is the square root of 4x, which is 2 times the square root of x. Good job. Now, if this did not go into the numerator, then we had to rationalize denominators. You know, let's say this was 3. Then it would not have helped us to put it all into one fraction. We'd still have a denominator. We would be multiplied by the square root of 3x over the square root of 3x. The SOLs are very clear. We don't rationalize denominators. That's not part of it. We did it because this is a higher Algebra 2 class and you're going to pre-cal next year, and you should know something about rationalizing denominators. But the SOL actually says simplify radical expressions not to include rationalizing denominators. So you should not be asked that question. But you could be asked this question.